Hello. So in our previous video we looked at the setup of two 10 ohm resistors in series. In this part of activity 2, resistance, we're going to look at our two 10 ohm resistors wired in parallel. So we're going to connect our circuit up again, so a lead from our negative terminal of our cell bank here to our switch. We're going to connect a lead from our switch to our first multimeter here, and this one's going to be our ammeter. So let's look at that again. We're going to use the amps DC scale, and we're going to use the 10 amp setting. We're using the 10 amp setting because most school digital ammeters are rated at 10 amps. We've got our 3 sockets on our multimeter. One is marked COM, and we always put a lead into COM, and one is marked 10 amps, and we're going to use that. Whenever you use an ammeter in a circuit, you always put it in series. So let's put a lead from our switch. We're going to put that into the COM socket. Then we're going to put a lead from the 10 amp socket into the terminal of our first resistor holder here. Then we're going to connect the lead from the red positive terminal of our cells here to this terminal of our first resistor holder. Now we're going to wire our second resistor in parallel. So we need a lead in here, and we connect it to the same terminal on the second resistor holder. We do exactly the same with this side. Okay, so now our two 10 ohm resistors are wired in parallel, and we have our basic circuit here. So if I switch our multimeter to the 10 amp setting and I switch our circuit on, you can see that we have a reading of 0.31 amps, and you notice that that's different to the current reading that we had for this series setup. Now we need to incorporate our voltmeter using our second multimeter. So let's have a look at that. Here you can see we have our volts DC scale, and we're going to use the 20 volt setting. So again, in most schools the digital voltmeter has a rating of 20 amps. We've got our 3 sockets again. One is marked COM, so we always put a lead into COM. The other socket we're going to use is marked volts, ohms and milliamps. Whenever we're using a voltmeter, we always put it in parallel to the component that we're testing. So we put a lead into the COM socket and we connect it to this plug terminal here, and then we put a lead into the volts, ohms and milliamp socket, and we put it into this terminal. So we switch our multimeter to 20 volts DC, switch our circuit on. Again, you can see that we have a current of 0.3 amps, and this time we have a potential difference across this first resistor of 1.55 volts. Switch the circuit off, and now very easily we can test the potential difference across the second resistor just by moving the leads across. So if we put our circuit on, again you can see that we have a current of 0.3 amps and we have potential difference voltage reading of 1.55 volts across our resistor. So what you might want to do now is you might want to move your ammeter around the circuit between the resistors. So what I'm going to do, I'm going to switch our multimeters off and I'm going to disconnect the wiring. I'm going to clean the circuit up so it makes it far easier for us to see where we are. Okay, so we're back to our simple series circuit. Disconnect that lead from our ammeter and connect the lead from the switch to our resistor. We can connect that lead, put that lead into the COM socket and connect it to this terminal here. And then if we put a lead into the 10 amp socket of our multimeter and connect that to the terminal of our second resistor holder. So now we've put the ammeter between the two in parallel, and now we're going to connect a lead back on this side of the resistor back to this terminal here. So now our circuit is connected. We can switch our ammeter back to 10 amps and switch our circuit on, and this time you can see that we have a current reading of 0.15 amps. So let's try moving our ammeter to this side of our resistors. So if we disconnect our ammeter, we can connect the lead back so that this side is back into parallel. We'll move our ammeter across. You can switch it off for now. Now this time we can put our ammeter lead into COM and we can add a lead from the 10 amp socket over to this lead plug terminal here. If we switch our ammeter back to the 10 amp setting again, switch our circuit on, again we can see that we have a current between the two resistors of 0.15 amps. Okay, and then the final position that we can put it is between the first resistor and the battery. So we can connect that lead to that resistor, so the resistors are wired back in parallel. We'll connect the lead into the COM socket and connect that here, and then we'll wire the lead from the positive terminal of our cells into the 10 amp socket. So again, if we throw our switch our circuit on, Again, this time you can see that we have a current reading of 0.3 amps. What we can do, we can introduce our voltmeter again. So if I connect a COM socket here and connect it to this terminal, and one in the volts, ohms and milliamps socket, and connect it to this terminal. So when we're connecting the voltmeters and ammeters up, to make sure that they have a positive reading, you have to wire them so that they're following conventional current, and conventional current runs from the positive terminal through your ammeter, through your resistors, back through the switch and back to the negative terminal on the other side of your battery here. So let's switch our voltmeter to 20 volts DC. We switch our circuit on. Again, yeah, we can see that we have a potential difference across our resistor of 1.55 volts, and we have a current reading of 0.3 amps. So what you'll notice is that the voltage is the same across the components, but the current is shared, is divided between the branches. So either side of our parallel circuit we had a reading of 0.3 amps, but between the two resistors we had a reading of 0.15 amps. And that's the difference between a parallel circuit and a series circuit.